Hi, Math 3 students. Today we're going to be going over how to solve literal equations. And basically what that means is we're going to work on trying to isolate a single variable. This is a common SAT question where they will give you an equation this equation represents, I don't know, the speed of sound in this environment or something like that. And it'll then say we want you to solve for x in terms of a, b, and c, or something to that effect. All right. And what you then have to do is, you would have to isolate the x variable. So that's what we're going to go ahead and do in a lot of these questions today. So for number 20, it says, solve the following equation for d. All right, so if we're trying to get d by itself, we have to think about, okay, well, what is around d that we have to get rid of? And the only thing we really have to get rid of here is the 1/5. All right, so d is being multiplied by 1/5. One way to get rid of a fraction is to multiply by its reciprocal. Okay, so we're going to multiply by the reciprocal of 1/5. Now, what is a reciprocal? Oh, wow, that is bigger than I had anticipated. There we go. The reciprocal of 1/5 would be 5/1, or just 5. Okay. A reciprocal comes from just flipping the fraction. So we're going to go ahead and multiply both sides by 5. Now, when you do this, if you have multiple terms, this is multiple terms. We have an f term and a 4g term here. You want to make sure that you put parentheses around it. All right. So then here on the right-hand side, 1/5 times 5 is 1. So the d is now by itself. All right. And we have 5f plus 4g. All right. Now this is an acceptable answer here, right? If you wanted to solve for d, you could say that d is equal to 5 times the quantity f plus 4g. It is important, though, that you recognize that sometimes you can simplify further. So, the SAT is a multiple choice test. So let's say you got this as your answer and this didn't match anything. Another way we could continue to simplify this expression is just distributing the 5. So you could get 5f plus 20g equals d. Both of these are completely acceptable answers. It's just important that you recognize that, again, sometimes you can simplify a little bit further. All right, so let's try this one. So it says, solve the following equation for f. So what we have to do is we have to try and get this f by itself. Now, I know a lot of you all are going to be tempted to distribute the f. Everyone loves to distribute when they can. But that's actually not what we want to do here, okay? What we have is f times this entire quantity. So it's almost like I had imagine if I had f times a equals n, right? That's essentially what we have here. Instead of a, it's just, 4g squared minus 9. Right? So if we think about it, how would we get f by itself in this first equation? Well, we would divide by a, right? We would have f equals n over a. So here, we're going to do the exact same thing. It just looks a little bit uglier. We're going to divide both sides by 4g squared minus 9. All right, so we have that f is equal to n over 4g squared minus 9. And that is our answer there. All right, number 22. It says, solve the following equation for b. Now, this is where it kind of starts to get a little bit trickier. All right. Sorry, I'm yawning. It's a bit early. It is 5:30 in the morning, so I'm sorry. All right. So the problem here is we have two b's. We have to get these guys by themselves. So one way you can do this is get everything that has a b on the same side, which for us, we already have that. And then what you can do is factor that b out. All right. Now, you know that this is equivalent, right? If I were to distribute that b back in there, I would get b, or mb minus 2qb, which is what I started with, right? So it works, all right? So we can do this. Now you can see that this problem looks very similar to number 21, right? It's a variable times a quantity, and we're trying to get that particular variable by itself. So all I have to do here is divide both sides by m minus 2q. All right, so we have b equals g divided by m minus 2q. And that would be our answer here. All right, so number 23 here. Here they want us to get a by itself. Now again, we have two a values here. So how are we going to get these a's by themselves? We are going to factor out. All right, then we can divide both sides. And we get that a is equal to b divided by 6 plus h. That would be our answer there. All right, we only got a couple more here. All right, now we want to get m by itself. All right. Oh, and I guess I didn't see that. There's two m's here. Oh, no. All right, so if you recall, I said that if you have multiple terms with the same variable that you want to isolate, what you want to do is you want to get all of the terms with that variable on the same side so that you can factor it out. So that's what we're going to do here. I'm going to subtract 4nm. And I get rm minus 4nm equals q. All right. Then I can go ahead and factor my m out. And I get r minus 4n equals q. And now we can go ahead and divide both sides by r minus 4n. M equals q divided by r minus 4n. That's our answer there. Alrighty, let's see. All right, so for number 25, we have to get a by itself. There's a lot going on here. So first thing I would recommend doing is subtracting both sides by 9. What you kind of want to approach this with is the same mentality as when you were doing inverses, right? Remember when you had to flip x and y and isolate the y value? It's the same rules, right? Where you kind of have to work like outside of the equation in closer to the variable. So yeah. All right. And then let's go ahead, let's get rid of my 1/3. All right, so one way to get rid of 1/3 is to multiply by the reciprocal. So my reciprocal of 1/3 is 3. Now again, remember, if you're multiplying a side that has multiple terms, you have to put parentheses around it. So we have 3 parentheses b minus 9 equals qa. Then we're going to go ahead, just divide, because we're getting a by itself, right? Yep. So we're just going to divide both sides by q. And that would be our answer there, 3b minus 9 all over q equals a. Now, of course, we could go ahead and distribute the 3 as well. Both of these answers I'm about to write, or I should say both of these answers provided, are completely acceptable. And it's important that you know that they can be written in two ways.